Alrighty, we got day 9 here, ladies and gentlemen, and right now we're talking about Kendrick Lamar. He wants a model of his favorite car built for his nephew. Kendrick's favorite car is his 2001 Chevy Impala, which has 20-inch blades. Slang for rims, if you did not know that, now you can say that. Alright, if the model car will be 1/12 the actual size, what's the size of the new rims? Okay. Now, both Kendrick and his nephew will want to keep these rims nice and shiny, sparkling clean, you know what I'm saying? So, we're going to need to compare the areas of the rims they'll be polishing up. Got to know how much polish we're going to be using to keep these rims nice and clean. Alright, so then we'll talk about what we notice about the areas. So, let's get to some mathing, shall we? So, 20-inch blades on his Impala. We're going to go 1/12 the actual size. This is like a scale factor type problem. Let's see here. So we got 1/12 is what we're dealing with. It's going to be the new size that we're going to go 1/12 of that. Now, it's important to set this up properly, obviously. So what goes over here, we're going to set up a proportion. Well, 20 is the big size, right? So that's one way that I look at it, is it's going to go with that bigger number there. Right? 1/12 is equal to something over 20. Okay, now we can cross multiply this thing. So let's see here, 20 times 1 is obviously 20, so we get 20 equals 12x when we cross multiply, and then it looks like we're going to have to divide by 12, do a little algebra to solve. So if I divide that by 12 on my handy dandy TI-84, I get 1.6 repeating. X equals 1.6 repeating, or you can think of it as like, 1.67 is fine. Okay, and that's inches, right? So that's the new diameter. Right? When we measure rims on a car, we're talking diameter. All right, this is not the radius. This isn't like a monster truck we're talking about. That's a normal size. Okay, so we got 1.67 inches, 1 2/3 inches for the rims. All right, now does that number make sense? Let's think about it. I think, yeah, that number makes sense. I mean, it's smaller, right? If I multiplied that by 12, I'd get back to 20, so that makes sense as well. Now, if I were to have set this this proportion up incorrectly, I'd get something kind of weird. Let's talk about that for a sec, little error action. So if I had 1/12 is equal to, let's say I flip-flop this, because I was just kind of, I don't know, we'll see. Well, I would get 1x equals 20 times 12. Well, 20 times 12 is going to be, what, 240? So his model car is 240-inch rims? I don't think so. That seems a little ludicrous. Okay? So we want to make sure our numbers make sense when we're going through these types of problems. And setting this up is easy to mix up here. So it's important that you do double check that and make sure they make sense. Okay, your calculator is only as smart as the one operating it, which is you. So make sure you're plugging in those right numbers. Okay. Let's continue. So we know what the size of the rims are. We've answered that question, right? We've answered this, but now we want to know what is the area that we're going to be polishing. Well, let's take a look at the two areas, shall we? Alright, I just wanted to move some stuff up there for us. Alright, so let's see here. We're talking area. Well, area of a circle. Area would equal pi r squared. That's a good formula to remember, right? Okay, area is pi r squared. Okay, so if we're talking about the area of the big ones, okay, so the 20-inch rims, well, that would be pi. My radius is going to be what? Well, half the diameter, so 10 squared. I always like to put whatever I'm squaring in parentheses. That's helpful, especially in like an algebra class if you're dealing with negative numbers. We won't deal with negative numbers very often here because, negative numbers wouldn't be a length, but it is important to remember that. Okay, so let's see here. If I take 10 squared, that's 100, and I multiply that by my pi, which is 3.14159. Alrighty, that is going to be about, so let's make this Make this a squiggly equals to represent that we rounded, right? That is important. So we're going to have 314 314.16 inches. That would be the area that we're going to be polishing up on the big ones. Now let's talk about the model car, right? Which would be this guy. So if we're dealing with the model car, if I take 1.6 repeating and I divide that by 2 to get my radius, I'm at 0.83. And then the 3's keep repeating, right? For a while anyways. Okay, so I like to do this on my calculator where I'll take the 1.6 repeating, I'll just divide it by 2. Keeps it a little more accurate. So let's see here. We're going to have pi times 0.83 repeating squared. So if I do pi r squared in my calculator, I am going to get approximately, what is that extra line? Don't want that. There we go. I'm going to get approximately 2.18 inches when I round. All right, we're dealing with some decimals here, so rounding is cool here, and it gives us a decent idea as to what we're dealing with. So there's my two areas. Now it asks us in this question here to compare our areas. Now, I think initially when we're thinking about this stuff, we're thinking, oh, if it's 1/12, everything should be 1/12. Well, 1/12 of 314.16, so if I were to divide that by 12 to get 1/12 of it, I get 26.18. That's not 2.18, is it? Well, I think we've talked about this a little bit before. We've talked about it in class. When I'm dealing with area, our units are squared. Okay? Now, the same is going to apply when we're dealing with circles. We're thinking in terms of something squared. Well, I have a question. What's 12 squared? Right, because that's like our scale factor here. So 12 squared is 144. What if I were to divide 314.16 by 144? And I'm doing that in my TI-84 right now. I sound like I'm endorsed by TI-84 because I keep on saying that. But anyways, when I do that, I get 2.18 roughly. Okay? So what I'm really looking at here is when I'm talking area, whatever I'm doing with my scale factor, whatever my scale factor is to get from one to the next, that squared is going to help me adjust for my areas. Now when it's not squared, that's going to be more like lengths, perimeters. So that'd be something like if we were to deal with circumference here. Okay, if it was circumference, it would be, the circumference of the big ones would be 12 times bigger than the circumference of the small, the model ones, right? The model tires would be 1/12 the circumference of the original, but the area is 1/44. Pretty crazy. We're going to be talking about that quite a bit in class because it is super important, especially when dealing with blueprints. Not only perimeters, but also areas. Alrighty, I like that one. That's a good question right there. Alright, ladies and gentlemen, we got Vanilla Ice contracting you once again to do another job at one of his Palm Beach flips. This time it's trim and carpet. So the bedroom that you did trim and carpet in was 12 foot by 10 foot, and it was a rectangular room. You charged him $300 to carpet and $320 to do the trim. Now the trim was $5 per linear foot and $25 for each miter. Now oftentimes those miters can change on price or copes, right? So if it's a really complicated trim, the price might go up, especially if you're dealing with any kind of copes and things like that. 'Cause a lot of curves and stuff to go around. All right, so you did such a great job that he decides to have you back to do another bedroom, and these dimensions are 3 times the size, but still rectangular in shape. How much did you charge to carpet, and how much to trim? Well, let's deal with those separately. So what I'm going to do is I'm going to draw myself a little rectangle, and we'll call this guy 10 foot by 12 foot. Okay? So that's like the rough sketch of the room. Now, if you were to do 3 times the dimensions, well, let's think about the carpet here. Would we just charge 3 times as much? I mean, intuitively that makes sense, but let's take a closer look. So 3 times is going to be something close to, I guess, like this. Whoop. Okay. Just roughly. Now, instead of 12 feet here, we're actually dealing with 36. And instead of 10 feet here, we're actually dealing with 30. Okay. right? Triple the dimensions. How many rectangles do we see in here? Well, if I start drawing this out, again, quite rough, but I'm getting the point across, I think. Holy cow. Instead of the one, now we have 9. I thought with 3 times we'd have 3 times the amount, like 3 rectangles. But no, there's 9 rectangles in here. So if the original job was 300, there we go. $300 for that carpeting in that room. Well, all these are going to be $300 if we're going up by the same pricing. And let's say for that we're doing the same price model. All right. Well, that's 300 times 9, which is going to give me $2,700. All right, $2,700. If you would have just multiplied 300 by 3 and charged them $900, you'd be in a world of hurt, right? You'd be losing money on that job most likely. All right, and we're not in the business here to lose money or break even. We're here to make some money, right? That's the whole point. Okay, so we've got that under control. We know how much to charge for the carpet job, but how much should we charge for the trim? Well, if it's $5 per linear foot plus $25 for each miter, let's see here. It was $320 originally. Okay. Let's see here. All right. Well, how do we find a perimeter? That'd be a solid start. So if it's 36 plus 30 plus 36 plus 30, right? Because you got to account for all 4 sides. That's 132 feet. That's our perimeter of this new room. Okay. And if it's $5 per linear foot, we multiply that by 5. That's $660 just for the linear feet, plus the 25 for each miter, which there's 4 of them, so 100. So we're talking $760 for our total trim job. Okay, so we've got everything that we need there. Now, I want to take a quick look at our perimeters versus the areas, okay? All right, so let's dive into this a little bit more as far as relating our perimeters, our areas, and when we're doubling, tripling, any kind of multiple to an existing space. So our original perimeter was, let's see here, 12 plus 10 plus 12 plus 10 was 44. Well, that is not a 4. I was thinking about feet as I was writing that. 44 feet. And our new perimeter was 132 feet. Okay. Now, if it was $5 per foot, then our original perimeter, cost of $5 per foot would have been $220. And I know in our math up here we had $660 for this guy. And then, of course, we're adding in the $100, but that's consistent across the board for these two, right? Because there's 4 miters. It doesn't matter that the room is bigger. There's 4 miters, so it's $100 for each one. Well, what do you notice about getting from one number to the next? So we multiplied that by 3. And that may, look at that. Our dimensions were tripled, so that went up by 3. But coming back over here to the area, we had to multiply it by 9. So what the heck's going on here? Well, if our scale is from 1 to 3, right, going from the small room to the big room, then our perimeters are also. So perimeter of the first one to the perimeter of the larger one is also the same. We'll also find that with our side lengths. So your side 1 over side 2. Okay? This is, of course, with similar figures. Okay? These are similar figures because you're tripling the size or quadrupling the size. It's a similar figure. Same shape, but a different size. Okay? All your angles are the same. Your sides are proportional. Now, when we're talking about area, okay, and I'm going to do area in green because that's fun. So area, if you had a 1 to 3, it would end up becoming, 1 squared. So let's say our side 1 squared squared over our side 2 squared, which would equal 1 over 9, right? Because 3 squared is 9, 1 squared is 1. So this will equal our area of the first over area of the second. Notice those little subscripts that's just saying like from the original to the new one, okay? So let's recap that. Our side over our side of our original to our new one is equal to the original perimeter over the new perimeter, right? It's the same thing, as long as we're dealing with similar figures. However, when it comes to area, right, when it comes to our area over here, we're really having to square our dimensions, okay? So the side squared over side squared is equal to our area over our area of our original to our new. Okay, so when we're dealing with those scale factors, really we got to square it to make sure we properly compensate for our areas. Otherwise, you're going to be writing up quotes that are way too cheap when you're dealing with like carpet or flooring or whatever of a room that's maybe 2, 3, 4 times the size. Okay, sound good? America, freedom, rock and roll, Vanilla Ice.